Good morning, everyone. My name is Dan Moshavi. I am the Dean of San Jose State University's Lucas College and Graduate School of Business, and it's my pleasure to welcome you and our distinguished panelists to what I hope will be a really engaging conversation on emerging technologies, a Silicon Valley view. Joining me this morning are Alan Cohen, Raman Khanna, and Raj Minhas. Our fourth panelist, Anu Basu, was unfortunately unable to make it this morning. She had an issue that came up at the last minute, but we're still going to have just a fantastic discussion. A couple of just housekeeping notes. One is this will be a facilitated conversation. I will serve as the moderator, but we will also be responding to questions in the Q&A. So please, as you're listening, if you have particular questions for particular panelists, please just put them in and we will get to them at some point during our presentation this morning. So I want to just give each panelist an opportunity to introduce themselves so you can have some context for their particular comments, understand their backgrounds a little bit more and how they see the world. So why don't we start with Alan Cohen. Alan? Alan, you're muted still. Alan, you're still muted, sorry. You're good.
All right. Sorry. Good morning, everyone, or good afternoon, or good evening, depending on where you are in the world. I'm Alan Cohen. I'm a partner at DCVC, which is a deep tech venture fund in the Bay Area and the UK. We focus on investing in companies that increase resilience, remove carbon and other physical threats from the environment, and democratize a set of goods and services through using deep tech. What deep tech means is the intersection of hard physical science and computing technologies, including AI. Prior to joining the firm a couple of years ago, I spent 25 years in enterprise technology, having worked for small companies like IBM and Cisco Systems, as well as being founder or first 5 employees of 4 startups. So excited to engage with everybody this morning.
Thank you, Alan. Raj.
Hi, Minhas. I'm a partner at a sort of a boutique M&A advisory firm focused on technology, but from the context of this conversation, my background is in AI. Before this, I was leading the AI research lab at Palo Alto Research Center, which used to be called Xerox PARC. And before that, I led Xerox's research center in Bangalore, built that up, built partnerships. So my background is in sort of early stage research and transitioning it to prototype level, transitioning it, working with partners and bringing it to market.
Thank you. And Raman.
Yeah, Raman Khanna. I'm a managing director with Dell Technologies Capital, which is the investment arm of Dell Technologies, the holding company for all of Michael Dell's assets, including, at least for now, VMware. Been in enterprise technology all my life, about 18 years of operating experience. I was, that included Chief Technology Officer and then Chief Information Officer of Stanford University. Been a venture capitalist for the last 21 years, mostly infrastructure, enterprise, cloud, a lot of cybersecurity, and lately a lot in data management.
Thank you all again for being here this morning. So I want to start our conversation really looking at broader technology trends that tend to span industries, right? And one of those trends, and Raj, we can start with you, given your background, is really in what we'll call applied AI, right? We're seeing artificial intelligence being used across tons of industries right now. So Raj, why don't you start us off with some of your insights on what we're seeing on the technology front there?
Just for clarity, right, when we say AI, we mean both sort of machine learning, which is sort of the latest trend, as well as symbolic planning kind of AI. The trends that we see now is the sort of, if you think of all the advances in the last few years, they have come on the machine learning side, right? So a lot of internet stuff, images, text, videos, and that has been very successful, but has relied on this preponderance of data. And so the latest trends that sort of are stage research stage sort of are trying to combine the two ideas, because one of the advantages of this machine learning kind of AI is that it scales very well. You don't need to know a lot about the system that you're modeling. That can come from the data. Whereas some of the advantages of sort of the symbolic kind of AI was there was a structure to it into which the system played, right? So the current systems, the machine learning systems, work very well within the data sets that you see, but they don't extrapolate out as well outside the data that you see and require a lot of data. The previous systems extrapolated really well because they were very structured, very constrained in some sense. So trying to combine the two to bring advantages of the two together, so you can reduce the amount of data needed, so you can make the systems more robust, and also then them to domains, sort of almost every domain, because you suddenly don't need gigabytes and gigabytes of data. If you can bring some structure in, you can bring some of these machine learning ideas to domains where that kind of internet scale data is not available. So think systems where you're interested in detecting failures, right? So you have a lot of data about normal behavior, but not about failures. So if you're trying to build a model of how a turbine fails, you may not have, tons and tons of data, but if you can impose some structure on it, you can still machine learning ideas and build models for them. And that has allowed machine learning kind of AI to sort of spread from this kind of scale kind of systems to almost everything these days. And as we go along, I'm sure we'll talk about
them. Actually, can I just one more question? When you and I chatted a while ago, you were talking about how AI is being used in design in particular. You want to just touch on that a little bit for now?
So that's a great example where in the past, a lot of that was done based on not about the physics, about the history of the systems, and now AI is being brought to it. So a lot of the early work in there that is being done is around this idea of how do you design a system given some end performance spec. So you say, I want to move water up a hill. Can you go from that to design a pump or some kind of a screwdriver or something? How do you do that? Machine alone cannot do that because you don't have data, but you have some understanding of physics, you have some understanding of how systems combine, but then machine learning can come together to do efficient searches, do efficient combinations, apply some notion of a directed search, what is in machine learning parlance called a gradient search. So you have some direction in which and improvements to happen. And so you can go from sort of this high-level spec of I want to move water up a hill to some designs that actually achieve that. The other side, you could think of these new technologies like 3D print, additive manufacturing, where you want to design some parts that meet some specs for ability to withstand some strain, ability to perform certain functions. And how can you then design these systems using these ideas of state exploration, looking at a lot of data, understanding how different parts will combine, where can you take some material off, where do you need to add it, how do you find that surface that allows you to meet that spec and aggressively reduce the part usage, the material usage, weight, whatever the case might be. Again, you can't based on pure machine learning. You combine that with some understanding of the domain, some understanding of how materials interact, how they combine. A lot of ideas that have been developed in machine learning to put the two together. So this kind of hybrid notion of combining logic, symbolism, and data analysis to do things that. A very interesting work is currently funded by DARPA called AI Research Assistant, right? So the idea there is, if you did not know, for example, Newton's 3 laws from observations of things in the world, so could you then a system that scientists could work with to provide, put data in, could create some constraints around what they know about the and the system could output some hypotheses about what a new law is that you're seeing. There is some kind of invariant that holds under many different conditions. So it's not just a black box. It's trying to help create an understandable system then that can interact with the human, the scientist who's working with it, refine it, and come up with something that is some kind of a law in some sense, rather than just black box statistical.
Dan, I might jump in here. I think that was a terrific explanation from Raj, and maybe just give a couple of other examples which might help folks think about it. So pretty much AI, almost every one of our investments use some form of AI, whether it's machine learning or an increasingly amount of computer vision in robotics. And I was going to provide two examples, one extremely complex, which should scare the daylights out of people, and one actually a lot simpler that. So we were investors in Element AI, which was Yoshua Bengio's company in Montreal. And not like I was going to the whiteboard and correcting the deep learning algorithms with Yoshua, but I did learn a couple of things on that board. One of the use cases is they were able to create a neural net that could simulate the conditions of ocean racing for the World Cup, which would include waveforms and wind conditions and the weight of people on crews on ships, boats, racing yachts, and racing hulls, I should say, to simulate how to actually build them, and do this all without ever actually putting a boat on the water. So an enormous data set, enormous complexity, series of interactions. On the other side, I'm the chairman of a company called Evolve Technologies in Massachusetts that has used machine learning to actually turn the physical security market on its head. That'll allow thousands of people an hour to walk through a portal, and will understand whether you have an iPhone or your keys in your pocket, or whether you have a knife or a gun. And the physical security industry, the metal detectors that we see in airports or in stadiums, were pretty much designed from technology that was in the magnetometers that were invented in the late 1890s initially to look for landmines in European land wars. Then ultimately in the 1930s to the 50s made them to prisons, and then ultimately after some hijackings in the 1970s got rolled out to airports. And we have all had that experience of waiting in line and emptying your pockets. The machine learning algorithms are constantly learning new forms of various forms of weapons, and people can now walk through these systems, and wherever you are in the world. If you're in the UK, you could go to Manchester and go to see Man City and walk through an Evolve, or you can go to O2 at a concert, or you could go to the Chicago Cubs or the Paramount Theater in Oakland, or the San Francisco Giants. And what's very interesting in a lot of the technology that Raj started talking about is that a lot of traditional tasks where humans were being used effectively as middleware are increasingly being replaced by forms of machine learning technologies where people are actually not particularly efficient at doing something. So if you think about somebody working as a security guard and an alarm goes off because they see a piece of metal and they ask you to empty pocket, and you look through your bag, it's actually not a very good job for human beings, because it's somewhat mind-numbing, and it's easily to make mistakes. So when people start to think about machine learning, yes, there are some unbelievably complex cases of where that technology can be applied. And then there are simpler ones where computer vision can be mounted on a robot, walk through a supermarket, other store, and understand whether something needs to be restocked, or can actually identify various forms of metal types, and allow people not to become effectively basically robots checking your bags and your pockets and your things. So when people think about opportunities, the technology angles are unbelievably exciting and being applied faster and faster every day. But the business opportunities, and I believe we are in an MBA format today, can be applied to industries that have not changed literally in 50 to 100 years.
No, I agree, Alan. If I have to add something, I think our themes-wise, One thing I just kind of wanted to mention, like for last 2 years or so, I'm waiting to meet with a company that doesn't claim to be AI/ML. So as you know, there's a lot of AI/ML whitewash going on. People might use few algorithms and call themselves AI/ML. Our investment are put in three categories. One is fundamental infrastructure. We have invested in semiconductor companies like Graphcore, which is a data center class semiconductor to enable deep learning, all the way to inference engines at the edge, very low power, where the data is at the edge and you want to have a low power inference engine. Lot of investments is AI-enabled automation, like as mentioned in security and stuff, like in data center management, people are getting millions of alerts a day. How do you reduce that noise down to 4 more important things you need to worry about so that humans can focus on that? And then I would call AI augmentation, which is like digital pathology, where AI could at least help the person evaluating the image, at least that this could be that, and let them make the final decision. We believe that over time, all software would be written in some form to enable AI functionality, whether in a vertical application or more middleware side.
The only thing I'll add to that is now AI is also being used to write software itself, right?
Yes,
write code.
that's going on. Yep, that's happening.
So, it's everywhere.
Terrific. Thank you, gentlemen. Alan, for you, we've talked a little bit about next level process automation and process visualization, robots. You started to talk about a little bit. Any thoughts there on trends, tech trends?
Well, I think maybe just at a high level to start, we're all going to have to get used to working alongside robots. I think the next 10 or 15 years, you are going to start to see robots show up much more in workplaces, particularly industrial workplaces or distribution warehouses. And that actually already exists if you work at Amazon or large e-commerce companies. But the innovation in process automation is going to be multi-threaded, and I'll give a less potentially creepy and scientific example of this. So a lot of human skills and a lot of professions are based on technique, and a good example of that is the field of medicine. I'm on the board of a company called Caption Health, where machine learning guides the use of an ultrasound for a cardiac, effectively an EKG level exam or a lung exam. And today, human beings are actually the process, and it really comes from skill on knowing how to make that capture. So increasingly, forms of AI are actually lowering the bar, which will allow initially more like a med tech or a nurse's assistant to perform this versus a sonographer or a nurse practitioner, or actually a doctor like a cardiologist themselves. So at a base level, things that are done today by people that are based on technique, we'll start to see that. On a more advanced case, we should expect much more full automation in supply chains, where I think this is where a lot of the changes are occurring. From a robotics and a workflow point of view, where we will see fully automated warehouses. If you look at, for example, a supermarket, a large supermarket in a large city or suburban area will employ 100 to 200 people over the course of a week. And increasingly, as we learned during COVID, as e-commerce showed up and people hired people and used online applications to have their groceries delivered. And as the virus pulls back, many people who are working are kind of like that convenience. That's a bad process format for e-commerce. So we will start to see fully automated and distributed warehouses start to enter, and they're still in the early stages. I mean, there'll be companies like Amazon that will be way ahead of the others. Then they have 800 distribution centers around the world, and they're in the process of building another 400. They just announced they're hiring another 125,000 people. So the way, manufacturing is going to be much more discrete and customized. So people are going to have to reconfigure factories. So the interesting thing for us in tech, and I think Raj Raman and I have had this experience, is we spent a really good part of our career building tech for tech, which was better processing, better software, better video conferencing, things that we're using today. And many of the traditional industries that effectively use tech as a back office tech type of enabler are going to see it actually move into their product development processes as well as their front offices. And to me, that's where the most exciting, parts of process automation are. And I don't know if you were asking me about RPA, and I'll leave that for my colleagues. I'm happy to chat about that, but that is effectively the elimination of human middleware and data gathering and synthesis.
Maybe I'll add a little bit to this. One of the things that Alan mentioned, which I sort of very much agree with, is this idea that this technology will enable people to do things that they previously couldn't, because you can get people with fewer skills or less expertise in AI to actually do them, or expertise is in medicine or whatever. But where I will add is that some of that expertise then is being incorporated into these systems. I think it is a understanding of AI. I think that it sort of only works with data. There is understanding about the systems that is incorporated in these neural networks, right? So if you think of vision, something called convolution, which is an understanding about vision, right? Things, you look at something and you look at things around it, that gives you some understanding of what you're looking at. You look at language, you think of sequences, long sequences, and then you come up with ideas of what to pay attention to or not. So some of that understanding that experts had about these domains, whether it's vision or language, etc., is incorporated now in the network. Same will happen in process. Sort of these Industry 4.0 and other things. These systems have been working for years. You've had a lot of experts develop heuristics over the years, and some of those ideas are very valid, right? Where previous expert systems were very manageable, they were very static. They didn't rely on data at all. If you can bring some of that expertise into the network design and then let data define something looks like where these places are going. So, for example, if you think of a process control like a chemical reactor or something like that, there is expertise in understanding how those things work, how they fail, understanding of what the failures are. Incorporate that in the design of your network, in the way you create your cost function, in the way you create things called regularizers. It's the technical ways of setting up these networks, and then let data, right? So you can bring of these people who have built up years of experience, and then let that expertise go to people who don't have that with the use of these systems, and let them run it, right? So I think it's going to incorporate existing expertise and make that available much wider set of people by lowering the bar of entry without them having to build up that expertise over 20 years.
Raman, anything to add here?
Yeah, I think they covered. It's not really our area of focus, but Alan, you would know it. We are investors in the French company Exotech, which is dealing with the warehouse robotics, doing very well. But yeah, it's amazing how every aspect of manufacturing and stuff, there are people like lately I've been seeing right out of Stanford University, a lot of projects coming out dealing with whether quality control, detecting defects and stuff. So there is a lot of activity in this space now.
All right, let's shift to the kind of future of connectivity, right? We know that the Internet of Things is just beyond exploded in terms of the number of devices being connected, right? We see this across industries, right? Healthcare has been mentioned earlier as a place where this exists. Alan, I think you mentioned there's even in surgery now, you're seeing this more and more. Why don't we start with you, and then I know everybody's got some interesting thoughts on this one.
Well, I think I share in common with Raj and Raman that all of us have spent time in the first internet. And I was lucky in my career 25 years ago to come to Cisco Systems, which built a lot of the basic backbone of the internet. What to me, some of the most exciting capabilities around IoT clearly come in some of the most incredible use cases, which include autonomous transport, and most people talk about autonomous cars. We actually are investors in an autonomous trucking company, and we have a stealth investment in an autonomous airplane company. Now, I'm not getting on that one first for a while, but some of that is coming. When I think about the most exciting parts of this, yes, it will be able to connect an enormous amount of things and sensors and perceptors out there. To me, the most exciting one in the Internet of Things that's going to come in the next 5 to 10 years is actually going to be wireless power, and which is something that has not worked for 20 years. And I'm not talking specifically about anything this morning, but the ability to actually connect things and power them will be literally the revamping of the Industrial Revolution. We've seen this. Anybody who gets into a car today that's been built in the last 5 years are relying on literally hundreds of IoT sensors to maintain that. Anybody wearing an Apple Watch or an Android watch has started to take telemetry from their own body and their health. So every aspect of our life is being touched by this, sometimes very subtly, and so we see an enormous opportunity to be able to take advantage of that. And Dan, you mentioned the case of healthcare. If you think about how most of the healthcare, and all of us are, let's say, above 30 on this call this morning, yes, that's as far as I'm going this morning. It's Friday. And if you think about what we do is we have a physical once a year. We may have a blood drawn for a sample. We have our blood pressure taken, various, pulse. That's actually a very poor way to deliver healthcare, because it's a point in time. You may have been up the night before grading your student papers, or trying to close the semester, or desperately fundraising for a campaign to do something, and your body may not be operating that way. So we're starting to see things that IoT is being able to provide a continuum of data, and in this case, a continuum of data that might be used in your health, that you're regularly monitoring your blood pressure or your glucose, or things that really matter. And that to me is what's really exciting, is when you go from static. I mean, the thing that made the internet interesting was it basically was able to connect everything and continuously communicate with it. But so many parts of our industry, our lives, our health, and how we do, have not had that access. And that's the kind of reframing of the thinking that's going on, which is why people are so deeply invested in IoT. Your refrigerator can run more efficiently and consume less electricity if it knows what's in it and how it's performing, as opposed to just blasting at high levels. So things can actually become more energy efficient. I can babble for a very long time, but that's how I think a lot of people I know are looking at IoT, is what would all that kind of continuous connection provide, and what could you do differently?
Raman, your thoughts on
the sensor side. Sorry, go ahead, Raman.
No, go ahead, please.
There was points that brought up with this idea of harvesting energy for powering these things. Because if you think about it, one of the things that is hard today in setting up smart buildings, setting up other things, is connect sensors, having them connected to your infrastructure, getting them connected to the power. And one of the very interesting things we were doing at Park was this idea of printing harvesters. If you think about it, almost every place now has passive energy, right? So you have Wi-Fi signals in your building. You can build these sensors that can harvest energy at a passive level. These ideas that work today in cell phone industry, where you have this idea of beam forming and sort of aiming at the beam at the people are with the. You can use that to actively power these sensors, so they don't just rely on passive power. You can print these sensors that you want for the specific need that you have, and then you can just put them on a wall. There is no connection needed, etc. And then there can be a central hub that sweeps through and powers them, so they can harvest this active energy, or if not, that's not there, they can harvest sort of this passive energy that is there in our Wi-Fi channels and others, and then sort of extract energy, make a measurement, send data to a hub, and then go silent, right? So suddenly this idea of connecting these devices becomes a bit more manageable if you can power them wirelessly, either actively or passively. And the idea that you can create demand for the tasks that are needed, right? So this 3D printing, additive manufacturing is coming up. At the place of need, you can print something, deploy it, and then power it in this. I think it's going to make this future of IoT that much more powerful.
Thanks. Raman.
Agreed. Yeah. So I think clearly very excited about with 5G that's coming there, because I think in addition to higher bandwidth, it's the lower latency that will be very critical. So there are two places. There is a lot of innovation going on the 5G side, like you mentioned about beam focusing. Like if you have a 49ers game going on in the stadium, you need a lot of bandwidth at that place. But when the game is over, you don't. And how do you, with beams, kind of disperse that bandwidth? But more importantly, I think the applications that will be enabled by 5G. Because once you have much lower latency, what can you do, whether it's on factory floor or other places? I think there is a lot of interesting stuff happening. Talking about on healthcare remote monitoring, I just met with a company that's kind of working on replacing a 3-day hospital stay to determine the right dosage for AFib medication by letting people do it from home. So those are the kind of things. Ultimately, I think as a VC, I look at is follow the money, which is an industry that has a huge market and where you can save money and make the process more efficient. So I'm actually, if you think about Ubers of the world, wouldn't have happened without 3G, 4G, or smartphones. Those are the kind of tech infrastructure that enable. I'm really excited about what are the new applications once 5G is out there, and you can assume everything is connected, that can happen.
Any other thoughts on this particular topic? Okay.
Well, I think there is one other thing that's going to happen that is really, well, two. One is there's going to be an enormous amount of additional data that's going to need to be processed. Dan, you alluded to, I'm an investor in a surgical navigation company. This company collects roughly 2 terabits of data during a surgery through the camera technology that it uses as part of the navigation system, and which is not something you normally capture. So the avalanche of computer vision and camera technology capturing, and so that just the sheer requirement to capture, process, store, which is going to make Raman really happy because he works for an entity that actually does extremely well when these things happen. To do that, that's the positive side, and also certainly an architectural and technical challenge, which I think will re-spur a lot of innovation in traditional tech. The other side, and a little bit darker, is the cybersecurity elements of this, which is that there's an enormous amount of data and collection points in real time that are actually occurring, and and that means being able to protect it, and both from the actual content of the data as well as the identity and privacy of the people involved in it. That latter part, I would say that our government operating systems and software are not quite prepared for yet, to say nothing about our business processes and systems, right? If you think about it, we all live in countries, they have governments, laws, which are effectively operating systems for society. And they evolve slowly. And sometimes because of due to shock, right? Something happens in an environment. And so what we see a lot of technologists forget sometimes, or entrepreneurs, is that because you can do something doesn't and may have an ostensible good product or service that people can easily wrap their mind around. The other side of it is, its impact to society is very important to process as well. And so I started this kind of side riff here about opportunities for people in the traditional tech industry to take all this data, manipulate it, store it, and use it. They're also going to have to power it. And given the changing weather patterns we've seen around the world, the concept of 10xing our energy consumption around tech, the way we produce electricity today, is not going to be sustainable in any way. So there's some amazing opportunities here, and there's also some risks and challenges that have to be overcome for them to really come to fruition.
Thank you. Raman, this is sort of your wheelhouse. Next topic, distributed infrastructure, cloud and edge computing. What are you seeing? What are you investing in these days? And what are you hoping comes down the pike in the next few years?
Oh my God, that's a huge area of technology. I think the next battleground is going to be edge. I think people started moving stuff to the cloud, but after you reach certain scale, people realize that the bills add up. So I'm sure you've heard the term, it's called repatriation from the cloud. That started happening. Actually, a lot of our startups that originally put everything on the cloud, but once they got to a certain scale, they are moving it all back there. I don't think there is kind of one right answer. Ultimately, it's going to be about hybrid cloud. I think what has won is a cloud architecture. But cloud architecture is not location. It could be, you can have cloud architecture on-prem, but really, as Alan was talking about, the humongous amount of data that's being produced, data has gravity. You can't just take all your data and move it to the core in the cloud. So data, I think where the world is going is mostly leave data where it is and bring compute and apps to it. So there are a lot of companies that we are funding, which basically figure out how to maybe do the security authentication and other centrally, but then move the applications and compute capacity to where it's needed. So a lot of that, I think, adjustment of where the compute is going to happen is taking place. A lot of disaggregation of compute and storage is happening so that you can scale two of them independently. And it's just, I think, in terms of innovation might not be as humongous as some of the other areas, but in terms of sheer dollars and the capacity that's needed, there is just a lot of action happening. And you can see it. All the hyperscalers now have their edge architecture, whether it's a Google Anthos or Amazon's product. So everybody knows that's where the battle is going to be going. So tremendous activity. And along with that comes, you have to evolve security architecture. You have to secure, I think, a lot of activity about leaving all your data encrypted and be able to keep it encrypted even while in use. So how do you kind of search encrypted data and those kinds of things? So along with kind of the architectural shift, there's going to be new opportunities, both in security. How do you manage these architectures? So tremendous area, I would say, for next 5 to 10 years.
Let's use that as a segue or into sort of cybersecurity.
Can I add one quick thing? I think this idea of edge computing is necessary for Internet of Things, right? So at Park, we did a very interesting project for DARPA called Ocean of Things, where these little floaters were in Pacific Ocean, and idea was that they would to monitor marine traffic, and so these little floaters that have a little bit of compute, a lot of power, some solar charging capability, and getting back over iridium, and so very, very limited. So you have to process them online there, and then if there is something interesting, send back some features that you can send over these very sort of small bandwidth channels, and you don't want to spend too much power. So there is a lot of innovation in edge computing to make sure that we can manage on low bandwidth, low power, and how do you connect all of them? So, if you have this floater and something is going by, you want to know whether that's a marine vessel, that's a pirate vessel. You have to bring that smart onto the device because the communication is you. The bandwidth is. Yeah.
Point. Thank you. Cybersecurity, right? This is an area that affects absolutely every firm that's out there. Anybody who collects data has got to protect the data. Right there, we still hear about breaches all the time, including of some of the largest companies. So clearly, this is the technology keeps emerging, and there's a challenge. So what's coming down the pike? Raman, you started to address this, but what else? What else are we looking at here?
So yeah, I mean, like cybersecurity actually is about 30% of our investment. So very, very active in this space, and that's one area. If you talk to CIOs, the budgets are still growing because this is like start with something like ransomware. Means it's getting bigger and bigger problem. People are kind of getting hacked and quietly paying off to get their data back. So a simple solution to things like that, people are coming up with architectures where bad guys don't have anything to steal. You take your data, shard it into multiple pieces, put it different places, differently encrypted. So there is no one place for these hackers to come and grab your data. So there is nothing for them to have. So I think this has been like, I've been investing in security since 1996. It's kind of a race between good guys and bad guys. You basically build something, then bad guys. I think the difference is bad guys collaborate up on the dark web. They basically share hacking tools and stuff. So it's easier for them to do that. Actually, many years ago, Secret Service had actually started a collaboration effort among large, especially financial services, like let's talk about kind of attacks so that we help each other. But the other big trend, I think that has to happen, security so far has been an afterthought. Companies build products, put them out there because they're worried about, because security generally comes with a cost. I think people used to say, security, usability, scalability, pick 2 out of 3. So a lot of companies did not incorporate security in their products because it some ways affected adoption. I think those days are gone. Now you have to integrate security into your products. There is that whole trend about what I call shift left, where you are bringing security all the way into the software development process. So they are incorporating it there. Of course, a lot of architectures on the hardware side. So I don't think we are much longer going to be at a stage where companies are building and shipping software or hardware without security kind of clearly thought out about. But that said, it's a constant race because in some ways what the global connectivity has done allowed a hacker from any part of the world to kind of come and kind of steal stuff from here. So I think distributed trust and stuff, but in general, like I would say with cloud stuff moving out, I think it's part of it is security, part of it is governance, because we have new rules like GDPR and stuff. You want to make sure that the data stays where it's supposed to. So a lot of companies that are basically building identity-based access control at a very granular level so that you make sure the wrong people, even within your own company, cannot get access to the data. So it's just like, I don't know, we have funded 40 plus companies in this space. Yeah.
Yeah, no, I think that Raman is given a great framework, which is, and I'm actually an advisor to a company called R2C, which is one of these shift left organizations. There's a couple of other things I might add to that. The first one is, the internet, which is effectively the computing platform we're all working on right now, was built with a sense of effectively openness. It was actually a collaboration between DARPA and then a bunch of universities to be able to allow people to kind of communicate and share information with each other. So it was not designed, and most computing systems were not designed for the kind of threat environment we live in today. And the truth is, there is not yet a regulatory or compliance framework strong enough to deal with this. I mean, if you want to manufacture a car, you have to, create a crash cage. You have to put airbags. People by law are required to wear seatbelts. There are safety precautions you need to take. Doesn't mean that there's still not going to be accidents, and unfortunately, and worse from that. So, the frameworks for this are not really in place. The other kind of key trend in my last company, Illumio, is very much part of this, is this concept of zero trust. That in today's world, the world we came from in technology industry, the answer was basically much more open and much more trusted. And now we were moving into an environment that everything is untrusted. The email, Dan, that you sent to the panelists introducing the panel goes through a piece of software in all of our organizations saying, do we actually trust this, or should we flag it? And by the way, the first email I got from you on this wound up in a junk filter, which is the downside sometimes of this. So I was, I think, a little late to respond. So I'm apologizing now for being late and responding to one of your emails to do that. But it is a complete change in perception. And then probably just maybe to close and hand this back is that we have entered an era of cybersecurity, and Raman brought this up when he raised the issue of ransomware, which is the top of mind, most compelling issue in cybersecurity today, where you have a mix of, state actors or state-sponsored actors mixing it up with private citizens and public, and corporations. So the boundaries between governments, bad people, and individuals and companies is just melting down, and being able to process how to work through that is very severe. But what we saw in ransomware, we have seen water systems, pipelines shut down by other government-sponsored bad actors, or just super empowered bad actors. I think that's what Tom Friedman called folks in the world, the Lexus and the Olive Tree in the world. This slide, he talked about super empowered bad people, which is technology. It puts the advantage on the attacker, not the defender. The defender has to work multiple times harder. So if we're going to see continued open use of computing, and I don't know if folks remember when the COVID pandemic came in, and organizations and governments and municipalities started closing down. We were all on Zoom, and there was all that Zoom bombing, where people would show up in the middle of a Zoom session, or it could be an Aircast that we're on today, and kind of hijacked it because there was very, very weak cybersecurity controls to get in, and obviously Zoom and others worked really hard. So cybersecurity is going to continue to grow, and it's going to be the messiest thing we're going to deal with from a framework point of view.
Slightly different perspective, which is, what can we do about it, right? So I think both Raman and Alan sort of talked about some approaches of sharp and sort of managing this, but I think it has a role to play as well, right? So for example, there was some work that we did for DARPA, which was sort of, use of AI to understand configuration, right? So a lot of these attacks happen because vulnerabilities that are known being addressed, and could an AI system sort of monitor and automatically sort of make sure that you're on the right configuration or flag it, right? That's the simplest thing you can do. But when it comes to security of physical, right? So cyber physical systems, reactors, power plants, things like that, you do have an advantage in that there are physical laws that these systems operate under, right? Unlike a completely cyber system, you expect if you change a variable in a reactor, the output will behave in specific ways. And so some of the ideas there are, how can you use AI to do that, is by sort of active. You send a signal that you understand and see the response back. And so your system is getting hijacked. If you're getting spoofing from your sensors and things, they will not know that. And so you can maybe detect it earlier, maybe you can act on it earlier. So a lot of these, the risk is the highest just because you have these sort of safety critical physical systems. You do have some advantage that you can leverage by using AI to sort of monitor them.
Yeah. Thank you. Question from one of our listeners that was sort of touched on as we talked about cybersecurity and AI, which is really around privacy protection, right? And there's an increasing demand for individuals to claim sort of their own data, how their own data might impact. How does all this impact the future of AI, the future of cybersecurity? Can you talk a little bit about that? Alan, why don't we start with you?
I love these questions because they're really simple two-line answers. No, it's a really excellent question and obviously very complex subject. So, there are a couple of things I think that are worth considering here. We are still in the early phases of rethinking how we deliver identity. In fact, the entire concept of the blockchain was not for buying simple art pictures of great masters or moving around currencies that may not really be currencies. By the way, just a little bugbear of mine, and I'm sorry to rant, that if you can't go into a store and pay for something with Bitcoin or Ethereum or Dogecoin, it's not a currency. It's a theoretical construct that may someday turn into a currency. But the technology around it, the distributed ledger and the privacy that people are working on are a very important technological direction for thinking through how to reestablish privacy and identity in various online and digital formats. I brought up the concept of zero trust. That is also, and I think it was either Raman or Raj brought up the concept of identity-based access control. We're going to start to see a lot more challenge systems enter that. It is probably the technological challenge / opportunity of our time, because if we don't get this right, things are going to become a lot slower in our day-to-day life and our economy. A great example of that is the just a contemporary example, and it's still fairly rudimentary but very interesting, is the idea of health passes. Because on one hand, your health information is regulated all kinds of ways, and it's tied to your identity. And there's been laws and regulatory schemes that have been put in place. But we're now increasingly asking people to present they are who they are, and they actually have, in many cases, been vaccinated to re-enter public and private places safely post-COVID. And we're seeing the emergence of fairly simple first-generation systems that are starting to do that, and I couldn't imagine a higher privacy concern about whether have you been vaccinated and have you been tested. Very, very personal information tied to your identity. What I would say is that the probably most interesting elements there that people are going to be delivering in addition to traditional technology systems is the entrance of biometrics to validate personal identity. And that might be a retinal scan, it might be facial recognition. And by the way, just think about the implications of these technologies and the amount of yelling has not begun about using those. But many of you, if you got on your iPhone and it's a relatively new model, you may have used your face to open it this morning before you logged in, if you're using their Face ID, right? So we're going to see increasing amounts of privacy tied to things that we're not traditionally used to. I mean, if you've flown on airlines, and there's a system called Clear, which uses a retinal scan to basically jump you to the top of the security line in airports. So I think we're going to see it in a lot of places. The concept of traditional ticketing for venues and probably badges to get in. I mean, I expect I'll visit you, Dan, and I'll walk up to the Lucas School of Business, and instead of showing somebody my ID or handing them a business card, if I have a return visitor, I'll do some kind of biometric scan and say, "Welcome back, Ellen." And that world is less than 5 years away, and still a lot of work to do, both technically and privacy-wise, to make that happen. But we're going to enter a new regimen to do that. I'm sorry I spoke so long. It's an area I like a lot.
Terrific. Thanks. Raman, Raj, either of you have some thoughts on
to it? From my perspective, what can we do to enable privacy in context of machine learning or AI, right? So there are sort of spectrum of things, right? So simplest, there's something called differential privacy, sort of methods that data, add some noise to it, so that when you build a model, some kind of AI model based on it, the impact due to your instance of data is not very clear on the system, in that people cannot reason about what your specific values were, and your height, your weight, your whatever, right? So at a very low level, this idea of privacy, different privacy preserving methods, there is some work being done there, so that your data to these systems, but people cannot reason backwards to infer things about you. And something that Raman initially mentioned, this idea of complete encryption and analyzing encrypted data. So this idea of homomorphic encryptions and doing analysis on them, they're very, very restricted. There are only very few things you can do in a reasonable way. It's not additionally very, very expensive. So there is some stuff going on there. But I think also on the modeling side, if, for example, I as a consumer say, I no longer want to consent Google to use my data, whoever to use my data, what does that mean? So simply getting my data out is not enough, right? So they have incorporated my data into models. So how can we build models where if you say I no longer consent my data being used, can the model be updated without having to retrain it, right? Because if you have to retrain it, that doesn't work. I mean, those things are highly complex and time consuming. So there are some incremental models being considered in AI where when you remove the data, the model trains a bit, but doesn't need to be completely retrained. So some of these ideas around how do you handle privacy in context of these systems where AI is going to be pervasive, there is something done. It's nowhere close to mainstream, but I just wanted to mention there is some thought being paid to those ideas.
Thank you. Raman, anything to add on the...
No, I think as we described, technology is catching up. From my perspective, the bigger issue here would be policy. Like a lot of people make a trade-off. They basically complain about privacy, but they give it up in return to get certain services. So I think this is a bigger issue than just technology.
Let's dive a little bit into clean tech. I know both Raj and Alan have some experience in this space. Alan, what are you thinking about? What are you seeing on the clean tech side?
Oh, wow. It's what aren't we seeing? There are a couple of things, and maybe I'll do this additively because I think Raman actually laid down talking about the regulatory sides of things. We're seeing at a base level, thinking about how society gets ready to deal with the decarbonization or lower carbonization of our economies. We're seeing, two kind of key trends. One is in the kind of compliance and scheme of that. We invested in a company we announced called Kairos Aerospace. It actually scans the atmosphere for methane. Oil producers, natural gas mining are great producers of methane. And actually, they actually have to change their practices to do that. And we're seeing that also satellite companies like Planet Labs or look at that. In addition, though we're not investors in this, we've seen a bunch of companies that are now starting to effectively do the accounting side of this. Is how do you understand the carbon footprint of an individual or an organization? by monitoring its business practices. So we're going to see the Salesforce of carbon accounting and emerging. We've seen several companies. That's the first part. The parts that are most exciting to me is the kind of rebiological interpretation of how we build products and goods and services. We are not investors, but the largest IPO in the history of the planet occurred this morning, a company called Ginkgo Bioworks out of Boston. These are companies that are substituting natural materials and molecules for chemicals in the creation of materials. And it's a fantastic example of automation and machine learning going into, rebuilding the reformatting the building blocks of the goods and services that we consume every day in ways that are much more environmentally friendly. Energy production, storage, enormous investment areas, very exciting. Battery technology, enormous amount of elements. My favorite, and I'll pass it over because I would talk about this all day, is there are sectors in our societies, in our economy, that are enormous contributors to greenhouse gases, as well as destruction of water systems. And probably the biggest offender is the most important thing in life. Nitrogen-based fertilizer was invented. That the nitrogen fertilizer that we use to probably feed hundreds of millions and billions of people are based on a chemical process called Haber-Bosch that was invented in 1910. And we basically create these nitrogen-based fertilizers. We put them on corn, sorghum, wheat, various grass-based cereal crops. And honestly, they probably saved 1 billion lives in the last 100 years by being able to feed people through additional production. The downside of it is they're an enormous contributor to greenhouse gases, and nitrous oxide is a lot worse than carbon dioxide. And they also leach into water systems, which create red algae and dead zones for fish. And by the way, those coastal zones actually also feed 1 billion people a year for subsistence protein. I'm an investor in a company called Pivot Bio that has actually synthetically, biologically developed microbes that you plant with corn, wheat, and sorghum at planting, and they naturally pull nitrogen from the soil. Think about it like human growth hormone applied to major food substances like these cereal crops. And through the history of the life cycle of that crop, it continually nourishes it because you can't have life without nitrogen. And none of it leaches in the air. It doesn't leach into the water because it's naturally sustaining. So it's a huge determination on lowering the climate clock, moving back the doomsday clock a couple of degrees. It does not, provide. Not only that, it provides crops that have been shown to be 10 to 15% higher yield. So it improves farmer economics. So, what we see is a fundamental rethinking of things that are so important to us in growing, food, sustaining life, that can be re-engineered through biology. And to me, that is the most exciting investment opportunity forever, because we're not going to live without food, and we're not going to live without fertilizer, but they can be something is that. And by the way, if you're an investor, nitrogen-based fertilizer is a $288 billion market. So it's bigger than storage, networking, servers, internet routers, the giant categories of tech, software as a service. Nitrogen fertilizer is a bigger market than all of those. And it has not had any technical innovation since 1910, other than efficiencies in manufacturing.
Thank you. Good stuff. Raj.
Alan, Marie, I'll add slightly different perspective, right? So, when you think of sort of clean tech, you can think of it in ways, right? So you can think of it in sort of improvements in how you manufacture, move things, right? So this idea of additive manufacturing or manufacturing at the point of use. So you cut down the transport so that sort of adds to the sort of the clean technology. So you think of additive manufacturing as clean technology per se, but it can have a big impact in sort of cutting down the energy footprint. If you farming, right, vertical farming, right, if you can maximize sort of the footprint in which you're producing things, if you can make that be sort of this kind of Internet of Things, sensing, you can reduce the amount of energy you use, the water you use, the space you use. That can have a big impact again on sort of the energy, but cutting down transport and space available for other uses, right? So that is currently just sort of open space in a horizontal way. Alan mentioned Haber-Bosch processes, right? So these are big systems. You manufacture these fertilizers and then you transport them, and the process itself is highly wasteful. Not only sort of the end effect of using that having impact on where you use it, and sort of the idea of these fallow cycles in your agriculture, but sort of manufacturing that has a big footprint. And so we did some work on sort of building these smaller scale systems that could be deployed at around the world instead of these huge Haber-Bosch plants that produce at a massive scale and are very wasteful. The other thing is sort of, these are sort of more passive, how can you prevent use, how can you prevent carbon generation, etc. On the other side is, once you have, what can you do, right? So can you remove carbon from the air? How can you do sequestration? How can you take carbon dioxide, convert it to pure carbon so it becomes solid and can be deposited anywhere, can be stored anywhere, can be used for other things? And so there was some work that we were doing at PARC, which was sort of looking at this idea of using molten metals on these specific furnaces. This was sort of early stage research funded by Department of Energy. So you would have these sort of suspended droplets of metals of specific kinds at specific temperatures that would react with carbon dioxide in the air, and carbon would kind of just float down. Carbon dioxide got extracted into carbon and flowed down to the bottom. Could you deploy these around the world? Can you extract then carbon from the air and sequester it in safer ways? So there is a lot of interesting work happening, and I think AI has a large role to play, whether it's in sort of ideas like additive manufacturing, vertical farming, better conditions on the ground from sensor data, from satellite data, things like that. There is a lot of very, very interesting work happening, both on the passive reduction and active reduction side.
I might add one. I think that's a great area, and if I might just hitchhike one other thought of I don't know how to classify him, but one of the most amazing things of our time, Buckminster Fuller said, pollution is resources that we're not harvesting, right? Because we're ignorant of their value. There's an amazing company in our portfolio called 12. It used to be called Opus 12. It is actually taking carbon dioxide from manufacturing plants, and rather than releasing it as waste gases, it's reprocessing them as reusable chemicals. So we're in the early phases of just imagining things that we used to consider pollution, and actually saying, can they be reused through to create chemicals, which go back to exactly the same factory, which will then build new materials of it. So ultimately, if we can take the contributors to climate change and climate disruption and turn them back into productive citizens in the economy, an amazing, exciting area. And to the point I think Raj made, the ability to think, the ability to process this and draw correlation and use machine learning in the development of this is just phenomenal.
Thank you. We've got a bunch of MBAs listening to this, and you all are clearly people who have developed some real strong technical technological backgrounds, but really your jobs now are to sort of figure out make the business case, right, for all this stuff and why it makes sense. So Raman, I'll start with you. So what are sort of, we have MBAs on this session, some of whom come from strong technological backgrounds, some of whom not at all, but they're going to have to manage this stuff, right? At some point, they're going to have to be. So what, any particular lessons or thoughts for the people watching today on that front?
I think my big thing is that I think there are a lot of opportunities in industry, as Alan mentioned before, where technology hasn't had that much impact. Whether take healthcare, huge industry, there are a lot of chances to use technology to take cost out of the system. Financial services, there are a lot of middlemen who make a lot of money. How do you disintermediate? Take a simple company like SoFi, dealing with student loans. They skim the cream, basically. So there are a lot of opportunities, whether it's the robo-advisors and stuff. You don't have to have a lot of interesting technology is available. It's how do you look at disrupting business models. I think there are a lot of opportunities in that regard, and just pure efficiency in the system.
Thanks. Raj, thoughts for in terms of people who need to now navigate this world we're talking about?
So one thing I will say is that sort of we have talked about, especially me, I mean, I've been talking about some of the early stage research and things, but maybe what I would say is that a lot of this technology now is very mature. So you can think of sort of this in terms of science, right? Applied data science, because a lot of these models that come out of Apple, Google, wherever, easily now reusable systems exist to easily reuse them. You don't need to do that. I mean, these systems are becoming much more easy to use. I would think of AI moving from the back end, right? So it used to be you go to Amazon, you say, oh, people who bought this also bought this, or you get a Netflix recommendation, to moving to the front end, right? So sensing, right? So we use cameras to sort of see and understand. We look at speech, we look at text, we look at now even touch and other things. So I would ask, people in the audience, kind of think of AI as technology and think of it as a sensing technology, right? So are there places where they're doing things where people now currently being used to make it? Could that then be automated, right? Could that then make things more consistent, more reliable? I would advise to sort of go to a site like Kaggle.com, Kaggle, which is a place where a lot of companies go and put their problems for the world to solve. Like as an open source site, they say, oh, here's a problem, and data scientists from the world go and solve that problem. And if you go to that site, you will see the range of problems that people are putting out. Maybe some of them resonate with you. But at least we'll give you an idea that the range of activities to which machine learning and, more importantly, data science, sort of established software and data practices are being applied is huge.
Thank you. Alan.
I think my colleagues have laid that out. I would actually posit an additional thought, being, by the way, a recovering MBA myself. What I would say is that when I look at these technologies, I look at business opportunities, whether you are thinking of going to work for a company or starting a company or doing research in a technology or a business area, I would be looking for areas that have very strong secular tailwinds. I spent part of my career early on at IBM, and for people who know about IBM's labs historically have been enormous halls of invention. They certainly were from the 60s through the 90s. Just incredible technologies were invented there. Many of which they did not commercialize. And we're not in front of them. So I agree exactly what Raj said, that a lot of machine learning and AI is much more mature than people think. And we're seeing computer scientists getting retrained in AI in 8 weeks, 6 weeks. There's programs to bring people through where they can be deeply involved here. But when you start to think about applying it against a problem or a business opportunity, you also want to say, are there things going on that are going to make people want to adopt it? Or am I pushing hard against that. And what Raman said earlier is always on my mind. And it's a little counterintuitive for tech folks, which is if there's regulatory pressure, there's business, right? Probably the best example in that I see is if you look at the growing electrification of the auto and eventually the truck fleets that are going on around the world. It wouldn't have happened if two things didn't occur. One, if governments around the world didn't increase the mileage requirements of cars and create a reason to innovate, we wouldn't have seen both improvement in fuel consumption, and which created the economic opportunity to make electric cars viable. That was driver number one. Driver number two is this guy, Elon Musk, single-handedly, some of it was hype, but single-handedly forced the auto industry into an electrification move. The world's largest auto company is the Volkswagen Group, and it got caught between both of those secular tailwinds and also having a diesel scandal, where they had to come back and change their entire company because they were mass polluting and covering it up. And I'm not pointing fingers. I don't know enough about that, but there were secular tailwinds that now have driven pretty much every large auto manufacturer in the world is building an electric fleet, committing. General Motors is committed to being purely electric by the mid-2030s. So when I think about where I can apply technology, whether it's in energy, whether it is in software, are there things that are driving it, because that will accelerate the adoption of that technology.
Great, thank you. Another question that ties to the larger issue of really are these technologies we're discussing, are they promising or are they dangerous, right? To sort of paraphrase a Bill Gates quote that got a lot of attention a couple of years ago, right? Do they create more equality, or do they actually create an even larger digital divide, particularly, not only in terms of income issues in this country, but in terms of just access in the developing world? So thoughts on, it's a bit of an existential question here, but, is this ultimately, a lot of times we'll say technology is fundamentally neutral, right? It's how it's used. But are we sort of tilting toward the promising or tilting toward the dangerous, or both? Raman?
So just kind of a disclaimer up front, I'm an inherent optimist, so I always think about the promises. But that said, there clearly are there are dangers. But what I am hoping is that those things would be tackled through policy. I think that's the only way to handle. We can talk about AI, all the good AI is doing. AI can be used to make some amazing weapons and cause destruction. I think clearly there is a job displacement issue. I believe that, yes, a lot of jobs would be lost, but what other opportunities would be created for better jobs? So that's, unfortunately, I'm wired that way. So that's how I think. So hard for me to go down the dark hole of how destructive these things could be.
Raj?
Any technology that increases activity in the end increases the standard of living for everyone, right? We don't have to look too far. When COVID happened, suddenly everything closed down. People still gone to private, still done private education, but technologies like Zoom and other things made it possible for everybody to participate. I grew up in India. As I said, I sort of led Xerox's research center there. 2011 to 2020, and we were working with a lot of hospitals who were trying to bring e-medicine to villages where people didn't have access to medicine before, or had to go many miles to go there or go see specialists. I think these things, in my view, is that have the means will always have what they need, right? It may be more expensive, but if the productivity goes up, those means are available to people who did not have the means before, right? If AI increases productivity, I think it will beneficial for all. Of course, any truly useful technology is dangerous and vice versa, right? I mean, the reason they are dangerous is because they are pervasive and useful. And because they're useful, they are pervasive and therefore sort of prone to misuse. But that's not just for AI, that's true for anything, right? Take your, poisons can be used as medicine. Atomic energy can be used to sort of, destruction or, complete necessary means for the sort of the prosperity in the world. AI is no different in that sense, and we have experience in sort of managing these kind of, maybe the scale at which stuff is happening is different, but in the end, if technologies help increase productivity, they help raise the standard, and also for people who before that these technologies.
Alan, thoughts?
I mean, I agree with both of my colleagues. I think they did a great job of laying it out. My only thought is how this turns out will have a big determination on how the operating systems of our society actually deal with both the challenges and the opportunities presented by tech. And we are going to take advantage of this, going to need to see some fast transformation in dealing with tech. I have my local congressman is a fellow named Eric Swalwell, and he's been in Congress about 6 years, in early 30s and kind of early in his career. And he said his first job when he got to the U.S. House of Representatives was teach people how to set up their Facebook accounts. So there's a little bit of, we'll have to see our governments and our leadership be able to be much more plugged into both the opportunities and challenge of technology. If we're going, so on the other side of this, our governmental operating systems will also be supportive of what things are going on. What opportunities are available.
Thanks. We have just about 5 minutes here before we wrap. Maybe our final question here. So there's all this amazing technology. We're going to be working alongside robots. What jobs? I mean, we also have people who are others who will watch this are some of our undergraduate students, early career MBAs. What jobs are disappearing in the next 5 to 10 years, and what jobs are coming online here for these young men and women? Any of you care to sort of be first on that one? Or have we stumped the panel here?
No, I don't think we stumped us. I think we're all working through. I would say, first of all, if your job can be done by a robot or software, you should be looking for another job. Because as long as the system is based for companies on profitability, they will use technology to moving toward profitability. What I would say is applying all of this new technology is going to create a raft of different jobs. So traditionally, we talked about software developers. I think if I was to ask Raj, he would say a lot more people should learn how to use machine learning and computer vision, right? Because as opposed to just writing C++ code, because that's where a lot of that is going to be applied. I would actually, I'm an optimist like Raman is. I would say is looking for jobs that are in new industries or that are transforming traditional industries are going to grow very rapidly because our economies are going to change with the advent of technology. And so being on that side of the curve is really important.
Yeah, I mean, if you look at...
Go ahead, Raman, and then Raj. Go ahead.
Yeah, no, I was just saying, if you look at how many very well-paying jobs of data scientists and other are open, like 1.4 million kind of shortage. So there is actually a severe shortage of skills. So I think what we need to do as society is to invest more in education and train people to basically go after these better jobs, which I think there's going to be more and more need for, because I think digital transformation is real and every business would be impacted, and it's going to create a lot of jobs. It's not just shortage of skills and talent in Silicon Valley. Even like people at places like India are having hard time finding programmers to increase their team there. So a lot of very good jobs are being created. Sorry, Raj, go ahead.
I was going to say, looking down the road, I mean, bio here, right? And so, if you were to say if somebody is starting high school now, where they should be looking, I would say look to bio. I mean, that is an area where we know very little is happening, where a lot happen both on the synthetic sort of construction side as well as understanding side, therapeutic side, and as level of productivity goes up, things that we maybe did not appreciate as much before will become more important, right? So sort of more personal interactions, more services, more arts, and applied arts and music and other things. As people have time, they have more time for leisure, and so anything that helps them sort of do better, will have value. But this is sort of like asking people at the turn of the century when agriculture, what jobs will people have? Some of it is our inability to know what will emerge, right? And so because there's sort of the paradigm very this worldview so much that it's hard to prognosticate too far out. But if my sort of personal interactions, services, and bio, those are the two things I do see.
And Dan, I think my colleagues would share this. I would make a pitch that I would be looking at emerging companies and startups more frequently than larger companies, because I mean, it's not, it's very specific to the situation, but so few companies that were on the Fortune 500 list 50 years ago are still there. And I think you're going to be thinking about your career in a much more fluid situation than, let's say, when the three of us or four of us, started our careers. We expected institutions to last a lot longer. And Salesforce just replaced ExxonMobil on the Fortune 500 list. And I mean, it's still a $150 billion a year oil company, but that is a statement of the financial market's belief on where the growth is going to be and the values of the society. So I think you have to kind of look at, you have to have a dry eye when you look at these opportunities in your career.
Gentlemen, thank you so much. On behalf of Alan Cohen, Raman Khanna, Raj Minhas, I'm Dan Moshavi, Dean of the Lucas College and Graduate School of Business at San Jose State University. Really appreciate you engaging with us this morning. And again, panelists, thank you so much, and everybody have a terrific day. Take care.
Bye, everybody.
Thank you. Bye-bye.